Hi, and welcome to this lecture on numbers. In this lecture, we are going to learn about what integers and floats are, arithmetic, common methods, common errors, and some mistakes you might make. Let's open the script editor and get started. Okay, I'm going to go down to our little icon in the bottom right. You can either open up a separate window, or like me, you can just open it up alongside your viewport. Okay, so what are integers and numbers? Python has various types of numbers or numeric literals. We're going to focus on integers and floating point numbers. In this course, they are numbers that we will encounter, or they are the numbers that we will encounter about 99% of the time and in our 99% of our scenarios. So integers or ints, they are whole numbers, positive or negative, for example, 2 or -2 are example of integers. Floats or floating point numbers in Python are notable because they have a decimal point in them, or they use an exponential, e, so to define the number. So for example, 2.0 and -2.1 are also example of floating point numbers. So 4e2, or 4 times 10 to the power of 2, is also an example of a floating point number. Throughout this course, we will mainly be working with integers or simple floating point numbers though. So let's go ahead and have a little look at arithmetic. Okay, we'll print out what we're working with. Let's go for addition. So I think most of you will have counted all arithmetic types if you were lucky enough to go to school until your teenage years. If you weren't, don't worry, because you're going to pick this up in no time, and it'll be very simple for you to understand what's going on here. So 4 + 2. Okay. Now, we are going to print out the actual equation output, not the equation itself here. So we are actually giving Python this as a command to say, what is this? Okay, that is what we're doing. We're not printing out what the command is. We are printing out the output of the command. Okay, so that is addition. Okay, subtraction, very much the same. Okay, 4 - 2, we're going to print the output. We're going to print the output. 2, multiplication. Okay, 4 and to a star to do a times. 4 * 2, 4 times 2. What a shock. Okay, and division. All right, so again, nice and simple. We'll highlight everything, sorry, Control and Enter to run our code, and we get a floating point number of 2. All right, so power of, so let's say we want to get 2 to the power of 3. 2 times itself twice. Oh, that's not going to work. Okay, so this should give us 2, 4, 8. There we go. So nice and simple. Okay, let's go for 4 then. So 2, 4, 8. You're going to guess it? 16. Yeah, that's the one we're going to get out of this. Okay, so, oh, wow, that's actually me putting it in wrong. So 2 to the power of 4, not 2 to the power of 16 or 8. Okay, so there we go, 16. Brilliant. Okay, so we can also do roots this way. So let's have a little look. So let's go 9 divided by, we get 3. So 3 to the power of 0.3, of 3 to the power of 3 would be 9. Okay, so we can get a power this way. Okay, order of operations is followed in Python. So let's say we do something, and let's do a little annoying equation of 2 plus 10 times 10 plus 3. Okay, what we're going to get here is 105. I hope, yeah, 105. Okay, so this is because we are saying so 2, okay, plus 10 times 10, 100, plus 3. So we are essentially saying 10 times 10, 100, plus 2, plus 3. It's annoying because it's all in order of operations, but we can reorder this, and we use parentheses to tidy this up, okay, and make it easier for us to understand, or easier for us to write clean looking code. So now we've got 10 plus 3, 13, and we've got 10 plus 2, 12. So now we can kick the output out of this, which is 156. So This is obviously a different equation, but this is probably how you should look to write equations in the future. You shouldn't be just writing long equations where the code gets very complicated. You don't know what order of things are being added, minus, subtracted, divided, because it's going to become very hard to understand. So try and use parentheses if you can to specify orders. Okay, let's go for variable assignment. All right, let's do this same kind of thing. So let's go a equals 1. Let's say b equals a plus 1. Okay, what are we going to get here? Pretty sure you figured it out. It's 2. It's straightforward. Okay, nice and simple. Now, we can quite easily now, we've got our variable, start appending this variable. So we've now added it to an object. And this same kind of methodology can be used for subtraction. But we want to try and shorthand this. We want to try and make it a little bit easier to understand. So we can actually go b, so we can actually in the future just say a plus equals 1. And if we, start off with, let's just clean this up a bit, we can actually go a equals, so plus equals 1. So we've got a equals 1. So now we've got a, okay, equals 1, we know this. All right, we can now do plus equals 1. And what that will do is take our a and say it, and do what we've just done there, which is a equals, or b equals a plus 1. So we're essentially doing this with this command. Equals a plus 1. This is what this command is shorthanding, which is quite nice because it makes everything a lot easier for us to read. Okay, we don't want to always do this because it's going to start becoming unreadable. Okay, but we can also do this for minus. So minus equals. We can also do this for divide. Obviously just give us back the 1. We can do this for times as well, which again, it's going to be a very uninteresting. We'll make that more interesting. Let's do it times 12. Way fun days. Okay, so simple, 12. Okay, great. So anytime you can reassign any variable. So here we are essentially reassigning this variable with the new output that we have gathered, but we can also just reassign this variable with, like we said before, a string or just another number. Okay, we've got to remember that as you're going through your output or through your code, you've got to check that you're not maybe reusing a variable name or assigning something accidentally without a calculation. Because maybe you want to assign something once in your code at the beginning, but then throughout the rest of your code, you may want to be actually calculating what the new value is. So try to make sure you check that as you go through your code. So using variable names can be a very useful way of tracking different variables in Python. For obvious object names can help keep a clear idea of what's going on in your code, and it'll be very useful for the next person reading your code. Okay, as I've said before, I've written code that I've looked back at, 7 or 8 years into the future, and I'm very confused because sometimes I was rushing, sometimes I didn't bother to annotate or to write comments essentially in my code. And so I was just confused about what was going on. I've abbreviated. I didn't follow best practices when I started out, just because I was working either by myself or in very small teams where it was really just me writing Python code. So until I did a proper kind of series of courses, I didn't actually really understand why it would be useful until I then start coming across the problems myself. So let's just save yourself the headache and make sure you name your variable very cleanly going forward in the future. Okay. All right, so let's have another example. Let's do some addition here. So let's go through this. Let's go through shopping. Let's go through shopping funds. Let's say we have 100 of whatever your currency is. Let's go, I'm going to be in pounds. So even here we could say, comment this out to make it a little bit more obvious. So this is in pounds. Okay, just to make it easier again for you to look at in the future. Okay, let's say fruit. Got some fruit that came to £23.11. I mean, this is expensive fruit. We have spent a lot of money on this. Okay, let's go veg equals £14. That maybe is slightly too much fruit to veg ratio, but I'm not going to judge you. Well, myself, I'm the one writing. Okay, we'll get some nuts. Okay, let's say I just spent $3.99 on nuts. Let's get some cereal. $5.99, because God knows they like to rob you on cereal, don't they? Okay, and let's try and now do a little calculation for my change. So this is, we've initiated all of these variables. Now we've got shopping funds equal to 100, fruit equal to 23.11, veg equal to 14.32, nuts equal to 3.9, cereal equal to 5.99. These are all assigned, so clicking, we get the result 5.99. Okay, so this is going to be really useful for us. So we can now get the variable my change, and we can say that is equal to shopping funds, okay, minus, let's now encapsulate, okay, because we're going to minus everything that we have just bought. So we're going to literally, okay, we're going to go fruit plus, okay, veg plus nuts and cereal. Okay, and then we will print my change. Okay, nice simple way of looking through all this. Easy. Okay, we've now got the equation, the change. Imagine we're writing a little function that takes in the input of whatever we've bought minus what the input is of what our shopping funds are, and then it gives you automatically out the change. So this is your change. Okay, and let's say this number isn't so useful to us because, okay, we'll know to round up in our head to 59, but okay, a built-in function that we can work out with numbers is round. So built-in Python function is just round, where we put in your number, put in what you would like to round this to, and you'll see how powerful little things like this are, because again, this would automate you doing something, okay, within your code. There we go. So we've now got your change. Brilliant. Okay, we've now showed your change. Okay, so now we can put a little comment there as well. Show me the money. Show me the money. No, show me the money. Okay, so I get type fright when I have to write in front of people, and I know I'm just doing this for myself at the moment, but I know there's going to be some people watching this, so very sorry for the type fright and incorrect typing. So this is all very readable. Okay, this is really nice code. This is really good to look at. This is what, you know, it's very obvious. If I look through this, I go, okay, shopping funds, yeah, okay. This would be very obvious to us, but let's say we start changing this now. Let's do what I have seen from some people's code in the past, which I've looked at and then refactored myself or made them refactor. Okay, we've got SF, shopping funds. Okay, you know it's shopping funds. We all know that this is veg. We know that this is nuts. We know that this is cereal. And this is your change. So what do you call this? C. Oh, yeah, okay. All right, now we see what we mean. You see what I mean about readability and how other programmers will learn to hate you. If this is the code you always output in your function, see, it only took us 20 seconds more to write the full the full names out of these variables that makes them readable. And this, yeah, it outputs the exact same thing. That's fine, it's great. But this equation here, what is going on? I haven't got a clue. I mean, like, yeah, I could probably guess what these things were, but this could be, you know, it could be self functions. It could literally mean anything. It could be satisfied factors. It could be anything. You know, this could be friction. It could be vectors. This could be numeric. It could be anything. So make sure you rename your numbers for the reason that we've said is that everything should be readable. Okay. All right. Now let's go ahead and look at some common methods. So we just touched on the round method for integers, for floats, which allows us to round any number to any length that we would like, or any floating point number to any number that we would like. Okay, but now we're going to look at the built-in functionality. I would really advise that you check Stack Overflow or the Python docs when you encounter problems or need to write a little method, as some methods that are built into Python might have been written already that you are trying to write. So there's no need for you then to go ahead and try to figure out some complex equation or some roundabout way of doing something when there's already a built-in function within Python for this. So as we just encountered, let's look at round. If you need to round up a floating number, just type in round. We put in the floating point number we would like to look at. And then we put the number of floating points we would like to have. So round and 2. And we're going to get the output here of 23, 23. Simple. Okay. If you would like to round this number to int, we can use our casting as we learnt recently. We can just type in int, and then we can say, oops, sorry, I need to remove the 2 here. We can actually just encapsulate this with int. So now this floating point number will be turned into an int. And you'll see it'll just round it up or down to the closest integer. Okay, all right. And even though we will shortly look at lists, here is a list of items that is dictated here by the square brackets. Okay. All right, and we are going to get the sum of all of these items. So again, another built-in function for lists that allows us to quite quickly get all the addition of all of those items. So nice and quick. Again, saves you having to write a loop and looping all of these items together. Nice and quick for you. Just returns you the int of what the output is. We can also check if items are floats or strings. Okay, you can generally check quite easily in Python if something is or isn't something else, which we will go into a little bit here. But it's worth checking out, again, the is integer, is upper, is lower. So for strings, you can check if it's an uppercase letter or a lowercase letter. You can check if is integer or if is float. But here we're just going to quickly look at, so let's have a look at num. So I'll just remove this bit of code here. A few kind of built-in functions which are quite useful for floats. So let's say our number is 3.2. And let's say we want to check if our number is an integer. So number dot is integer. Okay, so we've got number 3.2. And now we're going to ask, is number integer? False. Okay, now this can be used when you're cycling through a float. Because let's say we've denoted that this is a float at the minute because it has a point, a decimal point. But if you're cycling through and you just want to say stop when you hit a decimal number, you can actually go through it and check like this. So if it hits 0 or a decimal number, you can say, or sorry, an integer, you can say, oh, okay, well, check it now. So keep checking through the float as you're cycling through it in small increments and say, is it an integer? Now, this is only going to work on floats because this functionality does not work on strings. It does not work on any other type. So just be aware of that this is integer functionality is only on floating types. But there is another way of doing it, which is even more straightforward and probably what you will use 90% of the time. And it's a built-in functionality called isInstance. And it's a function which returns true or false, depending on the specified object and if it's that specified type. So let's have a quick look at this. So we've got our num, and now we're going to look at going isInstance of, okay, so is num instance of float. And we will see what this returns for us. So true. Okay, it is. All right. Okay, so we are going to quickly check and see. Okay, we're going to quickly check and see if num is a float. Okay. Oh, sorry, I've reassigned it, haven't I? Here we go. I could actually print it out, of course. Here we go. True. Let's go. Let's encapsulate this with a print just so that if we... Annoyingly, one thing that Python will do is if you run a piece of code and you highlight the line after, unless you're printing it, it will not print it out. It'll just kind of run through the code but won't print it for you. But if you print it, it will always run that code for you. Okay, so this is a type, but if we go then is instance of float when it's an integer, what we will get is a false. But one of the great things with the is instance is that you can check for multiple items at once. So let's quickly check string. Is it a string type? False, no. But we can check for saying, we can ask actually, is it any type of these numbers? Is it an int or is it a float? So we can actually encapsulate, you see here, with the parentheses. We're now using a tuple and we're saying, is this number, well, is it an int or a float? And we will get 2. So this is grouping them together and we're checking for multiple items, which you will find useful later on, trust me. Okay, especially when you're kind of moving from or moving between Python 2 and 3, you will have certain things that don't exist in one or the other. You want to check maybe what their type is before you execute a line of code, or you maybe want to check for a variable type when you're creating a function where a specific variable type is required. You want to make sure that you are having or working with the right instance, and that is where is instance comes in amazingly, because it does do everything it says on the tin. It checks if it is an instance and returns true if it is. Okay, so let's go to some common errors. All right, we'll clean up our window at the top. Okay, so as we've already stated in the past, you cannot divide by 0. So 3 divided by, nope, can't do it. It just will not happen. Okay, you cannot add a string to a number. So if we want to go 3 plus 3. These are 2 different types, and we cannot concatenate. Okay, an integer and a string. Okay, we need to first cast the 3 and make it into an int if we know that it is an int, or if it can be. So we go with 6. So it works. It's fine. But you cannot do some types will not add to others. Okay. All right. So I must first change that number. We talked about that. If the value is important to you, checking this in your code and stating this in the variable name for readability will be useful. So we covered is instance a minute ago. So let's have a little look. So is instance. So let's say we have some money. We want to say, is that money a float? Because maybe we only want to work with money that is a float, because the functionality that we need coming up uses decimal places and it requires this. So we can check for that. You need to make sure that you check for this explicitly. So we put in our if statement. If, so let's copy this. Money is float. So if our money is float, then we can print this is a bit of useful output for you. Okay, so then when you get this feedback, you're like, okay, this money is coming in as a float. This money, sorry, this is not an attribute. But yeah, we've got now a little check. So is instance is returning true or false and allowing this statement to run indented by 4, cleanly written out. Okay, brilliant, great. That was numbers. Okay, so integers and floats. And in this video, we have learned about how you add them, how you subtract them, all basic arithmetic, and the common methods to use with numeric functions and data types. So, and some common errors that you might come across. Okay, such as I said, okay, money can't be starting, or no integer float can start with a 0 at the beginning. It's just bad practice, and Python doesn't allow it. Okay, because it's basically, you might as well not have that there. Okay, much like starting any any variable name with a number is not allowed also. Okay, just try to remember those 2 key ones when assigning or creating a variable type. Okay, those are 2 ones to remember and think about. All right, thank you so much for listening, and I'll look forward to seeing you on our next video. Bye.